All right, let's get started. We are on lecture 15, and we're going to wrap up the first half of the course hopefully today, although we may spill over to the first few minutes of the next class. Problem set 2 was due today. I think it was due right now, so hopefully you guys loaded that up on B courses. The midterm is next Tuesday. I think I briefly mentioned it last time. There's 3 types of questions. There's short essay type questions, like the question in problem set 1. And throughout the course, we've talked about big themes or big questions. I've raised them on slides or in class or on the clicker questions, et cetera. So I think you guys have some sense of what the short essay questions might be. We also went through some theoretical models, like the growth model, solo growth model, the HIV model. I think those are 2 of the main ones we went through so far in the course. And then there's different types of econometric methods and applications. Problem set 2 is an example of that, of kind of like working through with data, basically getting some data and imposing a model on it. Basically, that's what problem set 2 is. Here's my regression equation. And if you do that, you get certain answers. And we've gone through randomized experiments. We've talked about omitted variable bias. We've talked about difference in differences. We've talked about regression discontinuity designs. We've talked about different types of data, missing data, selection effects, like with who got tested for HIV. So there's actually like 7 or 8 different econometric concepts and models floating around. And there'll be a question on the midterm on one of those concepts. And just basically ask you to apply some of those ideas to some data that I'll give you. I'll just basically write down numbers in a table or show you a graph and then ask you to think about how you analyze that data, basically. So yeah, so it'll be here. It'll just be during class time, so from 3:40 to 5. And you won't need to bring blue books or anything. I'll just have the exams printed out. So just you'll write on them. We'll collect them. I'll have scrap paper as part of the exams. You won't need to bring any scrap paper. So that's pretty much it. Obviously there won't be any calculators or notes or anything like that. It'll be closed book. And we're very strict about that. So I'll mention that again before the exam. I'll just ask you to put everything like way out of reach. Actually, in the final exam of this class last year, someone was caught with notes and got a 0 and failed in the class. So that was miserable for everybody, including me. But it was Pierre's fault. He saw her. I'm just kidding. So seriously, that's pretty much it. What questions do you guys have? Yeah. I think there's going to be an extra review section that Pierre and Jonas will have, and I think the problem sets are a good indication, and then a lot is going to come from slides. So I think in some ways obviously the readings are important, especially for a lot of the big essay questions, like the big themes. But in terms of a lot of the econometric concepts or the models, like the lecture slides are really the kind of go-to, I think, resource for that. Yeah. I think they're one behind right now because I just checked yesterday. I think it's up to lecture 13 or 14, I forget. So they usually post them with a lag. So we should just make sure this one gets posted. I think this may be the only one that wouldn't be posted. Otherwise, they've been posting with a little bit of lag. So I just have to remember to have them do that. So I'll ask them to do that. So then I think they'll all be up. Yeah. And then all the slides are always up. I just post them the same day. So the slides are up right away. Hopefully. Yeah. The problem sets are great examples, honestly. And obviously you won't be able to use data like you did in problem set 1, but I think like the question for problem set 2 is a really good example of how I would give you some statistics or a table or figure, and then you would have to figure out from that data what method to apply. So if you saw, for instance, data that looked like this, just as an example, if you saw data that looked like this, you might want to use regression discontinuity. That would be like a reasonable thing to want to do. If I say we've randomized into 2 groups, I think so I think I'm not going to try to trick you as much as there's like 4 or 5 concepts, but then I'll ask you to just walk through how to do them. You should know the equations from the slides. But I've been trying to keep the notation pretty similar across the different concepts. They've been kind of building on each other. So it's really, I think what I'm going to try to do on the midterm is really make sure you guys understand the concept. So it's not going to be a simple, yes, writing the equation will get you points, but I'm going to give you a setup where you're going to have to understand the assumptions underlying the different model. Like regression discontinuity has some assumptions, difference in differences has some assumptions. You're going to have to understand those assumptions. You're going to need to express them. Like this estimate is valid under this assumption, things like that. So I think I'm in some of the class discussion, I've been trying to prep you guys for that. And but the problem sets and the discussion in lecture will be a pretty good preparation, I think. Yeah. I think there's some longer readings. A lot of them are shorter, but then like the Bloom and Sachs is really long, and some of the Easterly is decently long. So there's kind of a mix in reading lengths. I think each of those readings has some main points, some of which have come out in class. In some of the big picture questions, knowing the readings well can help, because then you can bring in, Bloom and Sachs also made this point on transfer costs or something. So I would say you don't need to memorize the readings. It's not at all in the style of this class or how I like to test you guys to be like, again, on page 533 of Bloom and Sachs, what were the 4 key, points in footnote 22? Like I'm not going to do that. But I want you to know the big picture, like what was their main point, what were the 3 or 4 key themes, and you have to be able to say something about those things. So, it's somewhere in the middle. I want you to have read everything, be familiar with it, but really understand the concepts more than anything. Yeah. I usually don't circulate the practice ones. It takes me enough time just to come up with one set of questions, but the problem sets are good practice. Again, the lecture notes will be very useful. I usually have 3 questions, literally 1 from each of these categories. So there's probably going to be 3 questions. Each one will be 20 or 30 minutes. And they're usually similar weight. Sometimes if for whatever reason there's some extra stuff on the theory or the econometrics that I think is interesting, those maybe slightly longer, maybe it's 8, 10, 12 or something across the 3 questions, something like that. But there's basically 3 questions with more or less equal weight, maybe a little bit less weight on the essay usually, but I haven't written the exam yet. So I think that's the idea. So I think kind of what you've seen so far in terms of the essay, you'd probably have 2-sided page or something. I may ask the essay in kind of 2 parts, like here's an overall question, and if so, what are the implications? So maybe like 1 page on the first part, 1 page on the second part, something like that. That's the general length. It's not going to be a 5-page essay. It'll be a couple of pages where I want you to make an argument. Yeah. We will distribute the solutions to problem set 2 before the midterm. In fact, in the next couple, I think Pierre may even have them pretty close to done. So on Thursday, you guys will have the solutions to problem set 2. So that'll be 5 days before the exam. Yeah. Yeah. Yeah, I mean, you definitely want to be familiar with some of the issues in the data. Like in some of the studies, we talked a lot about the different types of data and the problems with the data. Those kinds of issues would be important. I'm trying to think of like how many specific numbers I would want you guys to know. For some papers, there's like 1 number that's important. Or for some, when we discussed HIV, like knowing that HIV prevalence was 6% and not 30%, like that's important. It's kind of important to know that there's some broad range of infection. I think for the Thornton paper, the one on Malawi and sort of the HIV test, knowing that when you introduce even a small cost, you get like a doubling of people going to clinics. Like, there were certain numbers in the papers or figures in the papers that were just very dramatic that I think would be worth knowing. I'm not going to, say you need to know exactly 81% rather than 79%. follow up on the HIV test and the Thornton paper. Like that level of distinction I'm not going to make, but the broad patterns I want you to be familiar with. That makes any sense? And again, a lot of the big patterns I put on the slides and we spent some time talking about. So those are probably the figures I'm going to be focusing on, for the midterm that I'd expect you to be familiar with. Yeah. Yeah, I definitely want you guys to read the papers, and they're going to give you more depth than I can even get into in the lectures, and that may be useful in the essay to have a deeper understanding. But obviously, I'm emphasizing the things in the lectures that I think are most important, and when we're going through the regression equations and whatnot, that's a lot of what I'm going to focus on, or I expect you to know. But also, what's in the lectures is a starting point. So there's tweaks to the growth model or tweaks to the HIV model. I may do some modification of the model, as I often do on midterms, just make sure you guys really understand the concept. So it isn't like if you literally know every equation in the slides, like one of those equations will be the answer. It might be that you need to modify that equation, but I'll try to explain how. But the lectures will be a really good base for one day. Yeah, that's right. A key number or a key figure or something. Slides are really what I thought of as the key things, yeah, for the most part. But I don't want to have you not read the papers because you're going to get deeper understanding that could actually help you, especially on the short essay. So, but I'm not going to sort of quiz you as much on those. Yeah. Okay, great. So let's just keep learning. Any other questions? Oh no, we're going to keep going through material today. Yeah. I won't have a review lecture, but Pierre and Jonas will have a review section. So, okay. So last time we started, we were talking in the last part of the lecture about this Lucas and Beatty paper about high-quality schools, these really fancy elite schools in Kenya. And we got through about half the material. So let me just pick up where we were. Remember last time I showed you this figure, and remember just to get everybody on the same page, the 0 here is the test score cutoff, above which you get into, you're admitted to one of these elite schools, below which you don't. And we went through and discussed this, and we commented on why there was that dip on the right side, and there were some interesting patterns in this figure. We were getting into that at the end of class last time, and what we sort of determined is that this discontinuity in the regression discontinuity design was about 0.5, so 50 percentage points. So some of these guys who shouldn't have qualified based on their initial test score got in, small numbers of them, partially because some people leave the elite schools and their slots are kind of filled by other strong students. So it kind of makes sense that these folks right here would have some chance of sort of filling in those slots. And we also found that not everybody who's admitted goes to these elite schools, partially because they're really expensive, maybe partially because these folks go to other, say, private schools or international schools, stuff like that. But there's still this huge discontinuity. So this is what we were discussing last time, and this is what's called a fuzzy discontinuity because it's imperfect at the cutoff. So a sharp discontinuity means it's literally 0 all the way up to the cutoff and then 1 above, like perfect assignment, right? But this is imperfect assignment. Still pretty good though. Okay, this is where we were ending up last time. If you run a regression of graduating from one of these national schools, so that was sort of the outcome in the previous figure, and you regress that on being admitted, where this is an indicator for that score in the previous plot being greater than or equal to 0. That's what this admitted to a national school thing means. You see, you get this like 50% effect, 0.497. And I think we were just getting here at the end of class last time. This is controlling for a lot of other factors. You get this 50% effect with a beautiful t-statistic of like 25. Okay? And they have a lot of data. They have 14,000 observations here. So a lot of observations. This isn't a small sample. Okay, so this is where we were wrapping up last time. Big effect. If you get admitted, you're much more likely to go. And but there's still some imperfect assignment. So these guys provide pretty precise estimates. They have this huge sample. They're able to match most people's primary school scores to their secondary school scores. And they're able to deal with manipulation. So I didn't show you these plots last time, I don't think, the manipulation plots. But I think I talked about a plot from another study saying that there was a big spike. I think I mentioned this Colombian health insurance study last time, that basically in that setting where people were only eligible for free public health insurance if they were below a certain score on a poverty survey, there was just a huge spike of people just poor enough to qualify. And that's evidence of manipulation. So the question is there evidence of manipulation here, where people somehow, just barely qualifying? The other way you can get at manipulation is by looking at other variables. So if you think that different types of people are systematically able to cheat and sort of just get over the threshold to qualify, then you might see that the characteristics of the winners on the right side of the threshold and the losers on the left side would differ significantly. Okay. Anyway, we didn't quite get to all this last time. So this first figure is the density of students, the number of students. And you can see that it looks pretty smooth right around the threshold, right? It goes right down. There isn't some big spike. There is one caveat, though, which is this dot right there, exactly at 0. And they have an explanation for this in the paper. They say this actually isn't a problem. Actually, I think they're right. But can anybody remember why they said you get a spike at 0? It's a very kind of technical point, but this comes up all the time in research studies. Can anybody remember? Does anybody remember how they define the threshold for admission to a particular school? I think I mentioned this last time. What was the definition of that 0 threshold? The 0 threshold is the score, the lowest score of someone who qualified for admission. That's the definition of the 0 here. Why would defining the score in that way, defining the 0 in that way, lead to a spike at exactly 0? Can anybody think of why? In a way that doesn't sort of jeopardize the design. Yeah. Okay, so if the scores had been announced in advance, that could have been an explanation. And that would be a form of like manipulation, like I'm just getting enough to qualify. But no one knew the scores in advance because you take the test and you're just competing against everybody else, and it depends on how they rank different schools as their preferences. And so no one actually knows that score in advance. Yeah. Yeah. Okay, they make a little bit of a different argument, so there is some density, but their argument relies on there not being a ton of density. Let me see if anybody else can figure it out, and then I'll give their explanation. You guys can evaluate. Can anybody else think of why, if you had sort of lower density around there, actually, for certain schools at least, or from, remember, every district, gender, has their own sort of specific entry score into these different elite schools. So, okay, so let me give, do you have a thought on it? Are you raising your hand or just, okay, so you're thinking, okay, yeah. That's right, so how does that work?
So like you just mentioned, each district within each gender has their own, so now you're saying every single cutoff is 0, and then it's distributed much more continuously, I guess. But then at 0 specifically, it's the exact cutoff for every school.
Okay, so I think that's basically right. So imagine the following. Imagine there's all these different scores, and each line I'm going to draw here is going to be like 1 point on the KCPE, right? Okay. So this guy here is the lowest score admitted. They get assigned 0. But they might have been admitted to that school. Remember, it's 0 to 500, so there's actually quite a number of different scores. They might have been admitted to that school, actually, even if they were here. They might have been a little lower and still been the last person admitted from their district gender group. Or maybe they would have been the last person admitted if they'd been 1 point up. So the true cutoff might have varied. It might have been a little lower or a little higher for that individual, because there are 500 points. What we're saying is we're defining it at 0 if you're the last person admitted. But it might have been 1 lower, it might have been 1 higher. So what you're getting is this grouping of like plus or minus 1 or 2 points all at 0, because that's how we're defining the 0 score. So another way to have defined the 0 score might have been to say not the score of the last person admitted, but the score of the first person not admitted, say. That would be another way to define it. That would give you a slightly different definition of 0. Or halfway in between the score of the last person admitted and the first person not admitted. That would have kind of smoothed things out. But instead, there's this bunching at 0, basically. I'm not sure if that's clear. That's their argument. Do people get the idea? Imagine that you got it. So some folks are getting it. It's a little bit of a subtle point. But the idea is if there's a couple points around me where there's no one else from my gender district-specific group who has a score like 1 or 2 points below me, then I might have gotten admitted even with a score a couple points lower. So in reality, the real threshold is kind of fuzzy. There isn't one sharp threshold. It might have been a couple points lower if I'd gotten a couple points lower. It might have been a couple points higher if I'd gotten a couple points higher. And then until I bumped into somebody else who had ranked that school as highly and had a good score. And that's why you get a spike right at 0. So in reality, you can see that the density is sort of maybe 4 or 5 times higher at exactly 0 than the other points around it, which sort of suggests that maybe plus or minus a couple points on each end could have been the equivalent threshold for each of these gender district-specific groups. Let me pause for a second and see if that makes sense. Do you have a question? Yeah.
Is that basically saying that if we're in trend of the table, basically taking those few points that are positive and negative just around 0 and kind of basically bringing up basically turning into 0?
Exactly. That's what it's saying. That's basically what it's doing mechanically by the definition of 0. So if in my district, let's say I got a 402, and I was the last male from my district to qualify for this really good national school. But from my district gender group, the next high score was 398. So actually, if I got a 401, I still would have gotten in. If I got a 400, I still would have gotten in. If I got a 399, I still would have gotten in. So in reality, all those scores that are -1, -2, -3 over there could have been the threshold. But I'm saying that, oh no, the real threshold is only exactly what I got. So you're getting all this sort of mass, meaning observations, at exactly that point. And it can go the other way, that I'm defined as the 0 point because I'm the lowest scoring male from my district who got into that school. Maybe there was someone with 3 points higher than me who also got in. He got a 405. So in other words, if I got a 403 instead of a 402, I would still be the lowest score. If I got a 404, I still would have been the lowest score. So there's all these like few points around 0 that might have been the threshold, but they're not. And they all get bunched up in that 1 point. And that's why they're not worried about that as being manipulation. It's just mechanical by the way you define 0. So if you define 0 differently as the midpoint between my score and the next score, it would look a little bit smoother probably than it does here. Yeah, do you want to follow up on that? Exactly. If there were a predefined cutoff, and this was the assumption made before in the first comment, and people couldn't manipulate their score, we would expect it to be perfectly smooth. But they're defining the threshold based on the scores, and that's why you get this funny spike. Did you have your hand up? Yeah. Exactly. Exactly. And so the quota is set, but the score that corresponds to those number of students from the district isn't set until you see how people perform. Yeah.
And so say if they had alternatively done the ranking, or taken students say by ranking instead of by score, and so they had a 1, 2, 3, 4, 5, and like top 20, then you wouldn't see that, right?
Then you wouldn't see that. That's an interesting way to think about it. So if the cutoff weren't the score, but we were saying, let's say there's 20 males from my district that can get into the school, let's say, and you ranked, characteristics, whatever the characteristic is, age, say on the bottom panel, or the density. Well, density is weird if you do rank, but let's say age, which we'll come to in a sec. By my ranking relative to the quota, you shouldn't see this kind of spike. It's only because the threshold is defined by the lowest score. So it's kind of an interesting point, and it takes a little time to wrap your head around it. It's worth rereading their discussion of it. It's kind of a neat discussion of why you see something that at first looks like manipulation, but it's due to their data generating process, basically, or the process of generating the threshold. Okay. So there's really no evidence of a kind of manipulation there. If we look at other things, like whether you went to a public primary school, where again, you wouldn't expect to see much of a jump. You see there's really no discontinuity here at the threshold. If you look at the student's age, you don't see any discontinuity at the threshold. It looks very smooth for all those characteristics. So it kind of feels like it wasn't like, private school kids were able to game the system, but public school kids weren't, where you see a big spike just on the side of 0, or older kids were able to game the system. At least on those dimensions, it doesn't look like there was some systematic sorting around the threshold. So that's good. That's good for them in terms of the validity of a regression discontinuity design. And this is a very typical check. You almost don't see any regression discontinuity papers where you don't see this kind of check, where they say, it's almost like, when we did randomized experiments, and we said, here's the average in the treatment group and the average in the control group, and we wanted to show they look kind of the same. Like we randomized, so we got groups that look pretty similar. Showing there's no discontinuity right at the threshold is kind of the same thing. We're saying like right on one side or the other is kind of as good as random around the threshold. That's the whole idea of one of these sharp cutoffs. So if people looked really different just to the right of the threshold and just to the left, it would make us think like the assumptions underlying the regression discontinuity don't hold anymore. There's something fishy going on. So it's like a balance table in an experiment. Any other thoughts or comments looking at these plots, looking at the data? Yeah, yeah. 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 Yeah, so I think we can almost back it out. So if we say that the number of students who are like kind of right around here, who are right around here is around what? 350, 400? I can't really tell. Let's say 350, right? And then this density here is maybe 1,300? I don't know, 1,200?